Hello guys, welcome back to OnTimeNotes, and today we are going to see concept of Bloom filter. It is a filter which gives you the answer to whether the particular element is a part of an array or not. And Bloom filter is a probabilistic data structure. It is used to test whether an element is a matter of a set, and Bloom filter is an array that stores zeros and ones. We can get two possible results. First is the item is not present in the set, that is true negative, and the second is the item might be present in the set. It can be either false positive or true positive. And Bloom filter supports only two operations, that is insert and lookup. So for insert operation, it can be performed in constant space and time complexity, and Bloom filter performs below step for insert operation. First, hash the input value. Second, mod the result by the length of array. Then third is set corresponding bit to 1. And in lookup operation, it can be performed in constant time and complexity, and Bloom filter performs below steps for lookup operation. First, hash the input value. Second, mod the result by length of the array and check if corresponding bit is 0 or 1. And if a bit is 0, then input is definitely not a member of a set, and if bit is 1, then the input might be a member of a set. Now we'll see an example for Bloom filter. So the question given is insert element 10 and 7 in the Bloom filter of size 5 and consider two hash functions h1 of x is equal to x mod 5 and h2 of x is equal to 2x plus 6 mod 5, and check the presence of element 14 and 15. So in this one we have to example we have to insert element 10 and 7 in the Bloom filter, and the size of Bloom filter given is 5, and also there are two hash functions provided, and we need to check whether the element 14 and 15 are present in the Bloom filter or not. So first we'll write all the given things. So m is equal to 5, that is the size of the Bloom filter. Then h1 of x is equal to x mod 5, and h2 of x is equal to 2x plus 6 mod 5. So now for inserting element 10 and 7 in the filter, just create a table like I have shown, and it would be easier for you to solve this example. So there are 4 rows, element to be inserted, h1 x, that is hash 1 function and hash 2 function, and in the last we will have a Bloom filter. So for 10, for h1 function, we'll replace the x as a 10, so it will be 10 mod 5, and after calculating we get the answer as 0. Now we'll replace x as a 10 for the hash 2 function as well, so we will get it like 26 mod 5, and after calculating that we'll get answer as remainder as 1. As the size of the Bloom filter is given, that is 5, and it is an array, so we will draw an array, and it will be indexed from 0 to 4 as size of the Bloom filter is 5, and the index for array starts from 0. So according to hash 1 function for element 10, the mod value, the value is 0, so we will replace the value at 0th index, that at start Bloom filter contained all 0 elements in the array. So now after performing the hash functions, as we have got the index 0 and 1 for h1 function and h2 function for 10, and we will replace those indexes with 1, bit 1. So now we'll insert the element 7. So after performing hash 1 function and hash 2 function on 7, we get the indexes as 2 and 0. So the Bloom filter was updated, that is 0th and first index were converted to bit 1. So now we'll take that Bloom filter for the second element as well, and now for 7, inserting element 7, For hash 1 function for element 7 we have got the index as 2, and for h2 function we have got the index as 0, but 0 is already updated. So now we just have to update the second index. So we will now get the Bloom filter as 0 1 2, the bit will be changed to 1, and for 3 and 4 the bit will remain 0. So now we will create another table for check for elements. Here we have got all the details in a one table, that is the present elements inserted are 10 and 7, and there are two hash functions, that is h1 and h2, and check for elements are 14 and 15. Means we need to check their presence in the Bloom filter, and there is updated Bloom filter. Now we will check the presence of element 14 and 15 in the Bloom filter. So we will create another table for that, and this will have 4 rows: element, hash function 1 and hash function 2, and Bloom filter. And for 14 we'll now replace the x with 14, and after performing the mod function we will get the remainder as 4. Get index 4 for both the hash functions. So now at the index 4 the value is 0. You can refer to the Bloom filter that we see above, and at index 4 the value is 0, which means that the element is not present in the set and it is true negative. Similarly for element 15 we will perform the hash functions, and we get the indexes as 0 and 1. So now the value is 1 at both indexes, that is 0 and 1, and which depicts that element present in set, but in reality it is not, so it is false positive. So this was it for the Bloom filter, and if you found this video helpful, please don't forget to like, share and subscribe to the channel, and thank you for watching till here.